I'm going to start with some of the issues that were dangling from last time, and it's got a lot to do with the moon and the Moonies and flat earthers usually. Okay, in general, that's those are the people who oppose or who object to the notion that humans ever went to the moon. But there are people who are not flat earthers. We'll call them Moonies. Okay, and so the Moonies also say that we never went to the moon, and they have some other issues as well with the moon. And here's the first issue. Fella says. He says, but the moon really spins. Uh-huh. One revolution takes 28 of our days. That is why we are always the same. We see always the same face. If it did not spin, you would see the backside of the moon in 14 days. Okay, so people believe that because the moon rotates around the Earth, always showing the same face, there is a 8-degree wobble there where you can see 8 degrees more of the moon one time and 8 degrees more of the other side of the moon. So the moon is actually wobbling a little bit, but essentially always shows us the same face. So people have this idea that the moon does in fact spin because its spin matches its rotation, its orbit around the Earth. Okay, so even though it always shows the same face, they say, well, the moon is spinning because it's constantly changing its direction with respect to the Earth as it goes around, as it orbits around. And the answer is no. The moon does not spin under any circumstance, under any interpretation of the word spin. Okay, and so let's move on to the second fellow here who also raises a similar issue. And he says the following. He says, you believe the physical Earth rotates. Uh-huh. Yeah, I think it does. It spins. Okay, so now we're talking about the Earth, not the moon. Okay. Okay. Hopefully I'm still online. I got a message there from YouTube saying that there's some kind of problem. Hopefully someone lets me know if you can't hear me or see me. I have no idea why I get these messages from YouTube. Okay. As far as I know, I'm online and everything checks out okay. Okay, so please let me know otherwise. Anyway, the fellow says, you have been told that since childhood. I was brainwashed, but he's right on that in that sense. We are all told since childhood that many things, and we accept them at face value because these are the grown-ups who are teaching us. So this is true. We are told a lot of things since childhood. Among them, that the Earth spins and that the moon goes around the Earth, etc., etc. Okay, so we do receive this kind of information in childhood when we are children. Okay. Okay, thank you. Appreciate that. I don't know why I get the messages from YouTube. Anyways, the fellow continues. He says, I assume you have considered the direct evidence, proof, okay, for that conclusion. Please tell me the one or two best evidences. Again, evidence that convinced you that physical Earth is actually rotating. Please explain why they convinced you that it's rotating. And I really would like to know what you understand is absolute convincing evidence for a rotating physical Earth. These people think that science is about convincing and persuading and converting people, and they want to be convinced, persuaded through what evidence? They say run an experiment or do an observation or whatever it is, and convince me, persuade me, force me to change my mind. This is the way they think. And we don't do that in science. We don't try to persuade or convince you of anything. Okay, so whenever you talk about evidence and convincing proof, those kinds of words, that belongs to religion. Never raise them in this site. Okay. Okay, so what's the problem? Let's go one problem at a time. Here we have the Earth spinning. Okay, so we're going to answer some of his questions. The first one we're going to answer, let's put it here. Okay, the Earth is a globe. It's a spherical object, celestial object. Okay, and the problem here is that I always explain this to these folks, and they never come back. None of these guys, none of these flat earthers ever come back. They just throw the question like saying, well, you can't answer it, and they just leave. And so they never come back to discuss the issue. So I don't understand. Are they interested in learning or not? I mean, do they really want to challenge their ideas, or are they just throwing the question because the air is free? Okay, so the Earth is a globe. Why is it a globe? Okay, the first one is that water and air encapsulate our planet. Water and air curve around the Earth. Okay, and they say, prove it, Bill. Okay, we don't prove. We give you an explanation so that you understand it. Whether you believe it or not, that's your personal business. It doesn't concern science at all. Okay, so we don't attack your credence, your faith, your beliefs. Okay, okay. So here's why water and air curve around the Earth, which means that the Earth had better be a sphere because that's the only way we can explain what I'm going to show you now. Okay. If you don't like what I show you, you should come back and say, Bill, this is what's wrong with it, or attack it in some way. Don't just throw the question and leave, which is what all these people do. Okay, here it goes, okay? Here's one atom of air, okay? And you also have water there. The blue stuff is water. The rings that I put around, the light blue there, those are air. And what you see is atoms being pulled towards the center of the Earth. Okay, no matter how you look at this, you have all these atoms that form our air, and the same thing happens with the water, okay? And they're pulled always towards the center of the Earth. And again, the farther out you go into space, the lighter the air becomes. There's fewer atoms as you go out, until at some point there are no more oxygen atoms out there, okay? Or O2, air, the molecule of O2. And so what I'm saying is that the reason we have air around the Earth, the reason Mars has a CO2 atmosphere, the reason Venus has a CO2 atmosphere, all these gases stick around these planets, it's because every atom that comprises that gas is connected to every atom of that body, of that celestial object. In this case, we have air, and every atom of the air is connected, physically connected by electromagnetic ropes to every atom that comprises the Earth. And of course, you're supposed to look at this in 3 dimensions. You're talking about a globe, and you're talking about all these nested shells of air. And in the same way, you're talking about the nested shells of water that are in the oceans. As you go deeper, you're going to have higher pressure because of that, because you have more and more concentration of atoms down there, okay, of water. And so, yeah, what you have here is an explanation of why the Earth is round, and meaning spherical. I'll call it round, but roundish in the sense of spherical, okay, 3D, and why every atom of air does not leave the Earth and fly off into outer space. They're all physically connected to every atom on Earth, and of course that's always going to tug towards the center, because as you can see here, every atom is pulled from the other side, even by atoms of air on the other side of the planet. And if you just do this, you'll find out that, yeah, everything pulls towards the center. And the center should be the highest pressure of all. Okay, so that's the best I can tell you. The Earth is a sphere. Sorry for you flat earthers. Okay, so that's the first issue. Now, what's the other issue? Okay, let's put it here again. The Earth also casts a curved shadow on the moon. Okay, so every now and then the Earth, the sun hits the Earth, and the Earth casts its penumbra onto the surface of the moon. Okay, so and it's curved. So from that point of view, you can imagine that the Earth is curved, and then that shadow, moves across the surface of the moon. Okay, so apparently something is moving out there. Now, what's the issue here? The issue is that point there, moon changes locations. What are we saying there? If you look at the night sky, and you can film this if you want, you can take your binoculars and just observe it for a little while, you'll find out that the moon changes locations in the night sky. It's not always at the same place in the sky with respect to other stars or whatever you see out there. The moon moves in the night sky. If the moon moves, then the Earth must of necessity move with respect to the moon. Okay, one is moving in that direction, this one is moving in this direction. Okay, so whenever something moves in the universe, everything in the universe moved or changed locations with respect to that object. So the Earth does move whether you like it or not. Okay, if the moon moves in one direction, or anything in the universe moves in one direction, the Earth automatically changes its location to that point. And that means that the Earth moves by definition, because the definition of motion is 2 or more locations. Okay, so the Earth is a globe, and the Earth moves. Now, there we have it. Moon moves to the left, left to the right, in the night sky. The sun moves left to right in the day sky. Well, what does that imply? Well, it means that the globe Earth, right, spins left to right, because the only difference there between, the moon and the sun compared to the Earth is that the Earth spins much faster than the moon. They all move in the same direction in the case of moon and the moon and the Earth move in the same direction, except that the Earth rotates in 24 hours, whereas the moon takes 27 and some fractions of a day to go around the Earth. So they're moving in the same direction, but you can imagine if the Earth rotates faster than the moon goes around it, orbits, then of course the moon is going to be shown going in the opposite direction. Okay, so that's why, you know, the Earth not only is a globe, but the Earth moves and the Earth spins. It's not that someone convinced me. It's not that someone produced some evidence. It comes through reasoning. In science, we don't present evidence. In science, we present arguments or theories that explain behavior or phenomena. Okay, so that's the situation. This is not something about convincing or persuading or you know, brainwashing or anything like that. It's got to do strictly with reasoning. You have to reason it out. Okay, I have no power to go with a rocket out there and look at the whole setup and say, yeah, after observing the moon for one full month, I found that it does go around the Earth, and meanwhile I saw the Earth spinning on its axis. You know, I can't do that. So I have to do it through reasoning. It's not through brainwashing, it's through reasoning. You reason and say, okay, if the moon goes that way, why does it go that way? Well, it goes that way maybe because the Earth is spinning faster than the moon goes around it. So yeah, the moon always lags behind the spin of the Earth. Okay? And again, you know, spherical, the Earth does move. You don't feel it moving? Well, I don't see my carpet moving. And you say, well, the carpet doesn't move. Well, it does move with respect to Jupiter. My carpet moves with respect to Jupiter. So my carpet does move. Every atom in the universe had better be moving because it's changing location with respect to all other atoms in the universe. Everything moves. There's no such thing as non-motion in our universe. Okay, so everything moves. Every atom moves. Every object moves with respect to other objects because that's the definition of the word move, which is two or more locations. Okay, what is a location? Set of distances with respect to all other objects. So those distances, those separations, not numbers, separations, those separations change. Sometimes you have a bigger gap, sometimes you have a smaller gap. That's called motion. Okay? So everything moves, whether you like it or not. Every time you move your arm, the Earth moves with respect to your arm. So you move the Earth. Okay? So please try to understand the definition of the word motion, move. Okay? Okay, another fella with this spin thing, moon spin. Okay? They try to give you the idea that the moon spins. No, the moon does not spin. Let's explain it one more time. Let's see if someone gets it out there, okay? The moon rotates on its axis, meaning he's trying to suggest that the moon spins, okay? The moon's rate of rotation matches its orbital period, which keeps the same rate facing the same side facing the Earth. Okay, so again, all these people have the idea that the Earth spins. It does not spin. Let's explain one more time, like I did the other day, why the moon does not spin on its axis, okay? We're going to put a rod right through the center of the moon. Okay, we're going to put a rod right through the center of the moon. That rod is cylindrical rod. Okay, we'll call that the axis. In other words, we'll make our axis not one-dimensional as things are in mathematical physics. We're going to make our axis, we're going to make it a little wider. We're going to make it into a cylinder of some kind, a very thin cylinder that goes right through the center of the moon. And you can put that rod any way you want. You can put it crosswise, up and down, east, west, north, south, I don't care. Put it any way you want. Okay, here's the deal. The rod is colored. Okay, it's got blue on one side and it's got red on the other side. Okay, and we're going to leave the rod fixed. Okay, so the rod's going to stand still. The rod's not going to move. That way we can gauge the motion of the moon with respect to the rod, which has been impaled right through the moon. Okay, running right through it. Now, one mountain, any mountain that you want on the moon, does not change its location with respect to red or blue, and another mountain on the other side of the moon does not change its location ever with respect to the red or the blue. Okay? So the moon does not spin with respect to that axis, that little cylinder that I just, impaled in there. Okay? That's what I'm saying. The moon can change its location or its orbit might match its so-called spin, its rotation, but the moon is not spinning with respect to its internal axis. If we could put a stake right through it, and we color code that stake, the mountains on the edges of the moon do not change their location with respect to those two colors. They're always gonna rotate together. Okay, and that's different than what you see in the Earth. This is the Earth. Okay, let me get it up here. See, the axis on the Earth rotates with the Earth. If I drew that stake right through the Earth, that stake would be spinning as well. That's not the case with the moon. The moon's axis does not spin, so to speak. Okay, that's what I'm trying to say here. Okay, I hope someone understood. Okay, and don't just repeat that. Oh, the moon spins. The moon spins. No. Answer the question. Does one side of the moon change with respect to the color-coded cylinder or axis that I put in through the center of the Earth. Either it does or it doesn't. Okay, it's a yes or no type of question. Okay, very simple. Okay, and so the moon does not spin. Spinning would mean that the axis itself rotates somehow. If we could drive a stake through there, and that's not the case. Okay, an independent one, by the way, right? Don't tell me that it's a strip of land going through the center of the moon. We're not talking about that. We're talking about an imaginary axis, cylinder. We just drove this stake right through the moon, and we're going to hold that one standing still. Does the moon rotate with respect to that cylinder? The answer is no. It does not rotate with respect to that artificial cylinder that stands still while the moon rotates around it. Doesn't happen. Okay. Okay. Here we have another fellow who talks about whether humans went to the moon. Okay, we have these Moonies out there, okay? And a fellow says it's impossible because of the radiation from the sun, and a lot of people have this argument, okay? They support this argument. They say it's like putting corn seeds in the microwave. After a while, they turn into popcorn. There is currently no such thing as protecting living organisms from radiation invading the black sky. Okay, he calls it the black sky. It's called space, but I don't know, maybe in his language it's known as the black sky. Okay, what can we say? Well, we have protection in microwave ovens for all kinds of radiation. I mean, if you bring microwave radiation, at least, which is not as high as some other radiations, right, like gamma rays or whatever, you have ways of protecting whatever you put in the oven against that high frequency radiation. And all I can tell you here is look up the following, and I'm just going to give you some clues here. What a spacesuit is made of. What materials protect you against high-level radiation out there in space. Okay, this is how a suit is built. Okay, and here it is. You have spacesuit materials that they use to build them, right, to construct them. Nylon, tricot material. You have spandex, okay. Urethane, coated nylon, okay, Dacron, synthetic fabrics such as neoprene, which is a sponge rubber, aluminized mylar, Gore-Tex, Kevlar, Nomex. All these are materials that are put into these spacesuits. Okay, they also have fiberglass. They have lithium hydroxide, okay, silver, zinc, plastic tubing, and polycarbonates, which are used for the helmet. So these guys are well protected against the so-called radiation. And, once again, you don't have to believe in this. You don't have to go out there to NASA to find out if this is true or not. Just put something in your oven, especially some metal, and find out if it absorbs the radiation. Okay, and you'll find out that it does. That we have materials that protect against high-level radiation. Okay, so to say that, we could not withstand radiation from the sun out there, radiation, first of all, you have to understand another thing. When you're out there in the middle of space, like between the Earth and the moon, right? Halfway between, well, you're really in the middle of space. You're in the middle of nowhere. And you're subjected to what is known as a solar wind. The solar wind is very tenuous. I mean, it's got, minus 12, maybe minus 13 torr range. You're talking about very few particles per cubic meter. Okay, that's the first issue. The second one is that sometimes you don't have only, the density of particles in that region, but you have maybe some swift moving particles that might serve as a bullet that goes right through you. And some of those might as well. But those are very few and far apart. And so, there's, again, like in the capsule, you're protected from that. Outside the capsule, you may not be as well protected. But obviously, when these astronauts are out there, the chances of getting hit by a boulder is like, it never happens. Even if you have a little zooming atom go right through you, well, we have that even here on Earth. We're bombarded by particles that go right through the atmosphere. It's not a foolproof protection that we receive from our atmosphere, and they'll just go through your body, maybe hit one DNA, one atom out of the DNA out of whack, and then that DNA starts growing, in a lousy way, which is known as, what is it, when, I had it in the tip of my tongue a minute ago. It's what's the word I'm looking for? Anyway, it changes your conception. It means that the next generation of DNA won't grow in the same way. Okay, so you have these changes in your body. Why? Because you do get bombarded by atoms from outer space that are not blocked by our air. Okay, another fellow says, NASA is now trying to return astronauts to the moon under Artemis program for the first time since 1972. Program is led by International Human Space Flight Program. Its primary goal is to return humans to the moon, specifically the lunar month, South Pole, by 2025. And the Artemis program would create a permanent presence on or around the moon. Okay, I'm saying that we're probably never going to go to the moon again. Maybe we will. I think we have the technology, the ability to get back to the moon. Why would we go? Would we go to mine? There are many reasons for going. One, are we going to evacuate the Earth and go to the moon? Never going to happen. Okay, so forget about that. Are we going to go out there and mine the moon? Maybe take some heavy machinery of some kind, mine the moon, and bring the rocks back. Well, again, if there's something that we're missing on Earth, we would probably do it, and if it's critical. But again, you got to look at the cost, because to take someone to the moon just to mine something and bring it back, it's a ton of money. Besides the fact that if you do it with humans, at least you can do it with robots. But if you do it with humans, you get the insurance and all that stuff for those guys that go out there. Okay, so you got to think, you got to make sure your technology works properly. And again, what are the returns? What are you going to get from the moon? You would do it if it's worth it, if it's if it's profitable in some way. I don't know. Let's assume you bring uranium, okay, back to the Earth because there's not enough uranium on Earth, or because it's all gone and it's all their half-lives are all shot out, and so now you need more uranium on Earth, and you say, well, let's get it from the moon, and let's say we found a lot of it on the moon, so we send some machinery out there and we start mining it. Okay, that might be a worthwhile venture, again, if it's worth our money, the global treasury invested on such an operation. Otherwise, why would we go to the moon? We have to supply these people out there in a little cabin, some kind of cabin that we build there. We call it a station or whatever. And the guys got to be there, like, on these orbiting stations. These guys would have to be out there for a long time, so several months for sure. And they would have to work under extreme conditions where, they would have to dress up every time they go out, go with the machinery. Think of these guys working more or less like, these bulldozers and other equipment that they have, the cranes and so on that they use to bring down buildings and raise new buildings out there. They would have to work with heavy machinery to mine the moon, bring it into their little place there, and then from there put it on the next capsule that comes over and take that to Earth so that we could use it here on Earth. Just ponder the costs. And again, it would have to be some material we don't have on Earth, which is very, very unlikely. Okay, and again, I think extinction is going to catch us way before that ever happens. So yeah, they might have some projects to go to the moon. I don't think they'll ever materialize. That's my 5 cents worth on that. Okay, final issue regarding the extinction phase of the lecture. Pal says the past extinction level events didn't do a very good job because we are still here. Okay, let's see what he's about. Extinction is the completely wrong word for describing said event, as it more akin to a mass culling. And I'm talking in the context of life, no matter what form it takes. No extinction level event ever happened, as extinct means the end of all life, and obviously that has never happened. Well, he's got a peculiar definition of the word extinction. Now, extinction, we use it per species, and we use it also for families and orders. And so the question is, if extinction is the end of all life on Earth, meaning including plants and everything, then what do we call, when an order or a family of plants or animals goes away? What do we call it when one species of plants and animals disappears? What kind of word are we going to use for that? That's the word we use. That's what we use the word extinction for. And if not, then you have to give me a word that we can use in science. Okay?